uniformity, matter and energy spread everywhere in the universe evenly. Eventually, something broke that uniformity. Stars began to form. Some of these stars became black holes, and some of these black holes devoured other stars and other black holes, becoming supermassive black holes. And they became the center of galaxies as they drew in more and more stars and black holes due to their immense gravitational influence. Galaxies began to devour each other, forming larger and larger galaxies, of which our Milky Way galaxy began to look like what we know it to look like 4 billion years since the beginning of everything. Since that time, our galaxy did not stop merging with other galaxies, even during present day, as it is currently devouring the Canis Major dwarf galaxy. However, 4 billion years from today, our galaxy will be eaten by the much more massive Andromeda galaxy, 2 times more massive than the Milky Way, with a supermassive black hole that's almost 10 times more massive than our Milky Way's supermassive black hole. However, that is not the end. Galaxies bound to us gravitationally, located in the local group, resisting the accelerating expansion of the universe, will begin to merge into one giant galaxy, a prime galaxy. As these galaxies are merging, the accelerating expansion of the universe would have pushed all other galaxies beyond the cosmic horizon. 1 trillion years into the future, only this prime galaxy remains, a galaxy whose inhabitants have never known any other galaxy for hundreds of billions of years. After 100 trillion years, the only stars that remain are extremely cool and faint stellar remnants that do not fuse atoms anymore. This includes white dwarfs, neutron stars, and brown dwarfs. At this point, the only way hydrogen-fusing stars, like our Sun, can form is through extremely rare collisions of remaining stellar remnants, a process which will decline more and more as time passes. The galaxy at this point is much fainter than it ever used to be. As time passes, low probability events which are extremely unlikely over hundreds of quintillions of years become extremely likely. This includes the gravitational interaction between objects in the galaxy in such a way that would have caused most of them to be ejected out of the galaxy. Then the universe's expansion takes over and moves them away from the galaxy until they can no longer be interacted with by anyone still living in this prime galaxy. 1 trillion quintillion years later, the galaxy would have lost more than 90% of its mass this way, and this likely includes remnants of the solar system. At this point, the less than 10% remaining mass exists as part of an absolutely enormous hypermassive black hole, hundreds of thousands of times more massive than the supermassive black hole that exists today in our Milky Way galaxy. The planets and stars that have been ejected out of the galaxy, roaming the universe alone, are now closer to absolute zero than ever before. This includes Earth, if it has not met the extremely likely fate of it being swallowed by the Sun, and whatever remains of the Sun itself. more than 100 trillion quintillion years into the future, protons, the building blocks of all matter in the universe, may start decaying, releasing a breath of fresh energy into the universe. Not as much as before, but some nonetheless. Stars can be fueled by this decay. A star with the mass of a white dwarf will be generating around 400 joules of energy per second, the amount of energy needed for around 10 incandescent light bulbs. Eventually, that slow decay rate would have made stars and planets lose most of their mass this way. Almost a Google years into the future, the black hole that once held our galaxy together dissipates through Hawking radiation, and at this point, only extremely low energy fundamental particles remain, spread out extremely thinly, almost never interacting with each other. Thank you very much for watching. Before I go, I just want to mention a few things. In this video, there are assumptions that have been made in order to make the predictions made work. I have not gone into the details of those assumptions. If you want a much more technical explanation of what has been discussed and you want to see some math behind everything that was discussed, I highly recommend that you read this paper. Link is in the description. Thank you very much. Take care.